For problem number 1, we are going to simply add the exponents there. That's our product rule. So we get x to the 13th power. For problem number 2, even though we have the 3y's, we just add the 3, the 6, and the 2 together as the exponents there. So that ends up giving us y to the 11th power. For number 3, 9 to the 0 power is 1. For number 4, negative 5 to the 0 power is negative 1. And number 5, the entire negative 4 is being taken to the 0 power, so that is 1. If we look at number 6, 8 to the 0 plus 5 to the 0 would be 1 plus 1, so that would equal 2. For number 7 here, we are going to apply the negative exponent property. That'll drop the 3p squared down to the denominator. We will simplify that to get 1 over 9p squared. It's a little different than number 8, where the 3 will stay on top and the x will go to the denominator, so 3 over x squared. And number 9 is a bit more like number 7, because the entire 5p will go to the denominator where it will be cubed, and we can cube the 5 to get 125, and then we also have the p cubed there. There we go. Starting with number 10, we're applying the quotient rule. So I can tell that my x's will end up on top. I just subtract the 8 from the 14, and I get x to the 6th. For number 11, I can tell that the x's will be on the bottom, so I just take the 7 away from the 14, and I get x to the 7th. With number 12, I would probably go ahead and just use the negative exponent property to bring the x to the 5th up and the x to the 12th down. Then I can look at that a little bit easier and know that the x's will end up on the bottom, and the difference between 12 and 5 gives me the fact that it's x to the 7th power, 1 over x to the 7th power. For number 13, that's the power of a power property, so I just multiply the 5 by negative 3. I get x to the negative 15th, which I then write without a negative exponent by dropping that down to the denominator, so we get 1 over x to the 15th. For number 14, I need to square the entire negative 2w to the 5th over x. So we would look at that as squaring the negative 2w to the 5th. So we would square that. We'd also square the x in the denominator. When I'm squaring negative 2w to the 5th, the negative 2 would get squared, and the w to the 5th also gets squared. Now be careful with that, because when we square negative 2 we get a positive 4. We have w to the 10th because we multiply the 5 by 2, and then the x squared stays where it is. Looking at number 15, I might do a few things at once here, maybe starting with dropping that x to the 5th down, but still to the 4th power. Oops, not equal to anything. And then multiplying the 2 by the negative 4, so I get negative 8. And then I would look at taking the 5 to the 4th power and the x to the 5th to the 4th power. 5 to the 4th power is 625. I'd multiply the 5 and 4 together, get x to the 20th, and then the x to the negative 8 would drop down to the denominator to make that a positive 8. And so from there I would just have 625 on top, and then the 20 and the 8 would be added together, so I get x to the 28th on the bottom. Looking at number 16, it would be a bit similar. One way you could handle that one is you could use the power of a product property, so that you would be taking x to the negative 3 to the negative 2nd power and y to the 6th to the negative 2nd power. And you would use the power of a power property, then you get x to the 6th and y to the negative 12th. and from there the x stays on top and the y drops down so that it has a negative or a positive exponent. For number 17, I would probably look at simplifying, again, just a little bit at a time here. Probably just leave the 8r to the 4th alone for now. Simplify the r to the 3rd to the 5th as r to the 15th. And then the 13 is going to stay for a minute here, and then multiply the 4 and negative 2 to get r to the negative 8th power. With that, the 8 and 13 won't reduce, so those are really just going to stay the same the rest of the way here. The r to the 8th could come up. I could add the r to the 4th and 15th, add those together, add the exponents to get r to the 19th, and then r to the negative 8 comes up to become a positive 8. And we end up with adding 19 and 8 together to get r to the 27th. And then just a plain 13 on the denominator there. With number 18, I would probably look at moving that t down to the denominator. So I'd have a t cubed and a t to the 4th there. It's still all to the negative 3rd power, and it's getting multiplied by really a 12t to the 5th once we take care of that negative exponent. From there, I would probably just simplify the denominator here to be t to the 7th, and that's still to the negative 3rd power, and being multiplied by the 12t to the 5th. The negative 3rd power would flip that over, and I'm going to go ahead and multiply the 7 by the 3 as well, so I'd have t to the 21st power, and 13 to the 3rd power is 2,197, and again they flipped because of the negative exponent, and that's still getting multiplied by 12t to the 5th. And so the t to the 5th and the t to the 21st would be t to the 26th. The 12 and the 2,197 do not reduce, so really then this is the final answer, 12t to the 26th over 2,197. Okay, at least with number 19 we get a break from the negative exponents. I would probably start by cubing the entire numerator there, so 3 cubed is 27. If I cube x squared, I get x to the 6th, and cube y to the 5th, I get y to the 15th. And then the 9xy squared on the bottom. From there, I reduce the 27 over 9. Notice the 27 is bigger, so the 3 is on top. The x's will also reduce, and all I look at there is the 6 is bigger than the 1, so I get an x to the 5th on top. 6 minus 1 is 5. And with the y's, the 13 is bigger than 2, so I actually end up with a y to the 11th on top as well. So I really don't need this area here, because I don't have a fraction anymore. It's really just the 3x to the 5th, y to the 11th is what we're looking at there. Now with number 20, we do have a few negative exponents. Again, there's a number of different ways you could handle this. One thing would be to just take care of those negative exponents right away. So the 2x cubed, and then the x to the negative 3 would come up, so we get x cubed and x cubed on the top. And then the y cubed and y to the 5th would be on the bottom. Now the whole thing is still to the negative 2 power, but before I deal with that, I would probably like to simplify the numerator and denominator first. So I end up with 2x to the 6th on top, y to the 8th in the denominator, still to the negative 2 power. So what the negative exponent is going to do is that's going to flip that over, and then also square each of those pieces. So y to the 8th comes up to the top, becomes y to the 16th because of the 2. When I square the 2, I get 4, and again the negative exponent just forces it to the bottom, so it's just a positive 4 there. And then the x to the 6th also gets forced down, and then doubling the exponent to 12. So y to the 16th over 4x to the 12th is what we end up with there. Looking at number 21, we're just looking to express the number in scientific notation. So we start with negative 6.2 times 10 to the, and this is a 7-digit number, so we get multiplied by 10 to the 6th power. With number 22, it's a small number, so 6.2005 times 10 to the negative, and I look at how many zeros I have. There's a total of 7 zeros, so it's times 10 to the negative 7th. Looking at 23 and 24, we're looking to change the numbers from scientific notation to standard notation. So with 23, it's going to be a big number. Of course, it starts with the 449. Since it has a 10 to the 6th power, it will be a 7-digit number. Well, I already have 3 digits, so I just need 4 more. Number 24, it's a small number, and I can see that it's got a negative 6. So I can tell then from that alone that it's going to have a total of 6 zeros before the 6327. Again, that does include the 0 properly placed in front of the decimal point that we have in our small number here. And I hope this helped prepare you for the 5.1 quiz. Thanks for watching.